much ado, let's begin, and let's take a look at the first tutorial on this topic. So the first tutorial gives us a clue of what is to come in this chapter. So we are doing chapter 3, part 1.
This video is on the topic of ions. Let's start by explaining what we mean by the term ion. An ion is an electrically charged atom or group of atoms. Ions are formed when an atom or group of atoms loses or gains electrons. Ions can be negatively charged or positively charged, and the sizes of these charges can differ. You can see this by the different ions shown here. Be careful, some students get confused and think that positive ions are formed by the gain of positively charged protons. But it is really important that you know that ions can only be formed by the loss or gain of electrons. The definition of the term ion is worth learning, as this is an easy mark to pick up in an exam. To explain why ions are formed, we need to consider the electronic configurations of atoms. Most atoms, including sodium and chlorine shown here, have an incomplete outer shell of electrons. This arrangement of electrons is not very stable. A full outer shell of electrons is a much more stable arrangement. To achieve this stable arrangement, atoms lose or gain electrons, and we can see the electronic configurations of the sodium and chloride ion here, showing that they have a full outer shell. Remember that the noble gases, such as neon and argon, have full outer shells of electrons, so we can see that ions have the electronic configuration of a noble gas. Let's look at how ions are formed in more detail, starting with the formation of positive ions. Metal atoms typically have 1, 2, or 3 electrons in their outer shell, which they lose to form positive ions. Let's take sodium as an example. We can see that an atom of sodium has 1 electron in its outer shell. It has 11 protons and 11 electrons, so is electrically neutral. Its outer shell is incomplete, as it has space for another 7 electrons. To obtain a stable full outer shell of electrons, it can either lose this outer electron or gain 7 more electrons to fill the third shell. It actually requires less energy to lose an electron than to gain 7 more electrons. So sodium loses its outer electron to form a sodium ion. As you can see, the sodium ion has no third shell, but a full second shell. It still has 11 protons, but now it only has 10 electrons. So it has 1 more proton than electrons, and therefore it will have a charge of 1+. We show the charge by putting square brackets around the ion. This indicates that the charge is spread evenly across the ion, and the charge is just outside the bracket in the top right-hand corner. When other metal ions are formed, the size of the charge depends on how many electrons the metal atom has lost, and we can use the group number of the metal to help us determine the charge. Group 1 elements lose 1 electron, so form an ion with a 1+ charge. Group 2 elements, such as magnesium, lose 2 electrons, so form an ion with a 2+ charge, and so on. Non-metal atoms gain electrons to form negative ions. Again, we will look at an example to explain this in more detail. Let's take chlorine as an example. An atom of chlorine has 17 protons and 17 electrons, so it has no overall charge. Chlorine is in group 7, so it has 7 electrons in its outer shell, which means it has space for 1 more electron. Less energy is required to gain an extra electron than would be needed to lose all of its 7 outer electrons, so chlorine gains an electron to form a stable full outer shell. Now it has 18 electrons and 17 protons, giving it 1 more electron than protons, so it forms a chloride ion with a 1- charge. If you are asked to draw an ion, it is really important that you remember to put the square brackets around the ion and show the correct charge in the top right-hand corner. Otherwise, we'll lose marks in an exam. Just like with positive ions, the size of the charge can be determined by the group number. Group 7 elements gain 1 electron to form ions with a 1- charge. Group 6 elements, such as oxygen, gain 2 electrons to form ions with a 2- charge, and so on. A way to remember this is that for negative ions, the group number plus the charge adds up to 8. For example, the group number of oxygen is 6, the charge on its ion is 2-, and 6 plus 2 is equal to 8. It is useful to remember that you can use the periodic table given to you in an exam to work out the charge an ion will have. There are a couple of terms that you need to know in relation to ions. We refer to positive ions as cations. For example, the aluminium 3+ ion and sodium 1+ ions shown here. Negative ions are known as anions, and the oxide ion and chloride ions are examples of anions. Students often find it difficult to remember which term belongs to which ion, but an easy way to remember this is that the word anion stands for a negative ion. As long as you can remember the meaning of one of these terms, you can work out the other name, and it saves you having to remember both. In summary, ions are electrically charged atoms or groups of atoms, which are formed by the loss or gain of electrons. Ions lose or gain electrons to gain a full outer shell of electrons, which is a much more stable arrangement. As they have a complete outer shell of electrons, their electronic configuration will be the same as of a noble gas. Metal atoms lose electrons to form positive ions, and non-metal atoms gain electrons to form negative ions. The terms cation and anion are used to describe positive ions and negative ions. Don't forget to check out all our other fantastic revision resources.
Okay, so let's quickly go. We've seen the tutorial. Let's quickly go through what we have. Okay, like let's revise what we told just now in our tutorial. Okay, now it said the formations of ion, right? How ions are formed. Ion will only be formed when an atom gain or lose electron. So if an atom do not lose electron, it's still an atom. When an atom or an element doesn't lose or doesn't gain, it cannot become an ion. Ions are only formed when an atom lose or when atom gain. So when they lose electron, that they have less electron in the outermost shell, in the shell, compared to the number of protons. You know, protons and electrons are same. The number of protons, while atoms are electrically neutral, number of protons equal to number of electrons. So for example, if you take sodium Na, it has how many protons? The atomic number is 11. So the number of protons will be 11, number of electrons will be 11 as well, right? Number of electrons will be 11 as well. So when the atom, that's the proton is 11, electron is 11. Remember, the electrons are arranged in shells. The electrons are arranged in shells. So 11 electrons, meaning the first shell will take 2 electrons. The maximum number of electrons in the first shell is 2. Cannot go beyond 2 for first shell. The second shell, the number of electrons is 8. Maximum number of electrons is 8. So if you add 2 plus 8 is 10, still remaining 1. So that one will be taken to the third shell. So only 1 electron is in the third shell. So it's easier for sodium atom the energy it needs to get rid of 1 is smaller than the energy to get 7. Okay, the energy to lose 1 is smaller than the energy to go and look for several electrons. Okay, so it's easier for the atom to lose 1 electron in order to be in a stable state. Why do atoms lose or gain electron? They do that to be stable. They do that because when they lose this one, this extra electron that doesn't make it 8, once they don't have 8 in the atmosphere, they are unstable. So it needs to lose this one. So generally metals, they lose electrons. They bend it, like magnesium has 12. So magnesium is 2, 8, 2. So in the case of magnesium, you will lose 2 electrons. The second shell, there are only 2 electrons. So it has to lose these 2 electrons to become magnesium. You know, when you lose electron, you become positively charged. You become a cation. When you lose electron, you become a cation. You become positively charged. So you become 2+ like this. So the ion is now, when atoms lose electron or they gain electron, they are ions. When atoms lose electron or they gain electron, they are ions. In the exam, they ask you to define the following: compound, ions, element. All of this, you should know how to state it very briefly. Okay, so when you lose or gain electron, like in this case is sodium. For this one is sodium. So sodium has only 1 electron in the outmost shell. You know what we mean by shell, right? We're going to show it in the diagram. This, for example, let's say this is your nucleus. There you have your protons and neutrons. Your shells are the energy levels. Okay, they are your orbits. You know, electron revolves around the nucleus. This is your nucleus where you have your protons and neutrons. Yeah, your shells are. So the first shell has a maximum of 2 electrons. Okay, the second shell has a maximum of 8. So in this second one, we spread 8 electrons around the sodium. Then the third shell will create a third one because it's still not complete 11. So the 11th one has to be on the third shell. So the number of electrons in the atmosphere has to be lost in order for the atoms to be stable. Okay, so when they lose electron or they gain electron, they are called ions. In case in the exam you have to define what ions are. Now, okay, so we say the loss or gain of electron, they usually take place in order for the atoms to have full outer shell electrons. When they lose, for example, if you lose sodium, will now have 2,8. If you lose one, the outermost shell will be full one. It will be 8. Okay, it will be like as if it's a noble gas. So it has lost the one in the third shell. So maybe it's chlorine that is looking for one, or any atom that is looking for one electron. So when you lose, you become positively charged. For sodium, the ion will be Na+. Okay, first of all, this is sodium as atom. This is the symbol of sodium. Now, as ion, because it has lost one electron, we only go to write. We don't write 1. No need to write 1. Just put plus. Na+, means 1 plus. Okay, it means 1 plus. In maths, no need to say 1 plus. You just say plus because it lost one electron. This is sodium ion. This is sodium ion. It has lost one electron to become sodium ion. Sodium atom has lost one electron to become sodium ion. Magnesium. This is magnesium. This particular one is magnesium atom. A magnesium atom loses 2 electrons in the atmosphere to become magnesium ion. To become magnesium ion. To become this magnesium ion. Okay, so I think that is clear enough, and let's move on. Now, when you gain electron, this is when you lose electron. When you lose, you become positively charged. I used to say logically, just logically, like in the law of life is the more you give, the more you get. Okay, when you lose, Almighty God raises you, right? Raises your status physically and spiritually. So when you lose electron, you become positive, right? Even in your feeling, you feel good when you help people. So when you lose electron, you become positively charged. This has nothing to do with chemistry, okay? This is just our analogy. We're just trying to mimic the real life with the chemistry. So we say when you give, like lose means you give, not like you lost it, not like real lost, like you give it out. When you give electron out, when an atom gives electron out, it becomes positively charged. Now, what if when you gain electron, so when you become the guy who receives, instead of giving, you are not the giver, you are the receiver, you become negatively charged. For example, like chlorine. Chlorine has atomic number 17, for example. Chlorine has 17. Okay, Cl has atomic number 17. Okay, so number of protons is 17, number of electrons is 17. For the atom. If you're an atom, number of protons and electrons are same. But when chlorine is not going to, because it's going to have the electronic configuration is 2 in the first shell of electron. Second shell will be 8. 8 electrons will be in the second shell, and there 7 electrons will be in the third shell. Now you can see chlorine is looking for 1. It's better to look for 1 than to give out 7. You already have 7. Why you give out 7? So it's better to look for to add to it and make it 8. The energy required to look for 1 electron is lesser than the energy required to get rid of 7. So it's better for chlorine to look for 1. So when the 1 comes from sodium, let's say this sodium gives the 1 electron. It has this one outermost shell, right? The outermost shell, there was 1 electron. So he gives it to this guy, to chlorine. Okay? You see how this will lead us to ionic bonding. He gives this one to chlorine. So chlorine ion will now be like this. Chlorine ion, if you gain 1 electron, you will now be minus. When you gain electron, you become an anion. Meaning you become negatively charged. Because you gain 1, that's why we just put only minus. If you gain 2, you say 2 minus. If you gain 3, you say 3 minus. In the case of nitrogen, against 3, say 3 minus. Is that okay? So this is what is playing out, and this is for chlorine as an atom. But when it gains an electron, it becomes chlorine ion. Meaning, why is it ion? Because the number of protons is 17. Electrons are now more. Proton is 17, but what about electrons? Number of electrons will now be 18, no more 70. Why? Because it gained 1 extra electron from sodium. So chlorine, for chlorine, the electron will be 18. So you can see electron is more than proton. That's why it's negatively charged. Why is it negative? Electron means negative charge. So when you have more electron, you become positive charge. Now, what about sodium earlier on when we talked about why sodium positively charged? If you want to explain it from a chemistry perspective, it now has more proton. You know, proton is a positive charge particle. Proton is positively charged. So it has more proton. Electron is now 10. You know, it lost one electron. It's supposed for ion. You know, it's supposed to be level 11. So since it has lost one electron in the outermost shell, electron is less. So it's now more positive than negative. Now more positive. That's why it is a sodium plus, because it has more positive. Proton is responsible for the positivity. Okay. Now let's move on. I think this one explains the basics you need to know about cation and anion. Cations are atoms that have lost electron, while anions are atoms that have gained electrons. Is that okay? Now let's go to the key formation. So the formation of cation. How are cations formed? Cations are atoms that have lost electron. They become positively charged. Now let's take the atom. This red one you see, we use a cross and dot. Okay, we use the dot and cross to represent electrons in the shell. This one, this purple color, is the nucleus. Inside the nucleus, you have 11 proton for sodium. You have 11 proton, and you have 12 neutron, because the atomic mass, or the mass number, not atomic mass, the mass number is 23. You know, this and this, they add up. Proton and neutron add up to the mass number. So if the mass is 23, like I wrote earlier on, I wrote the mass 23. Look at it. I wrote it here. If the mass is 23 and the number of protons is 11, then neutron will be 23 minus 11. We did that in chapter 2. 23 minus 11, that gives you the number of neutrons. So inside the nucleus of the atom, you have number of protons to be 11 for sodium, and the neutron, we're not talking about the electron, the neutron, which is neutral, which does not have a charge, is 12. Now, this is for the nucleus. Now, for the electrons, they are arranged in orbit, they are arranged in shells. The first shell holds a maximum number of 2 electrons. The second shell holds a maximum number of 8 electrons. So, for sodium, that is 11, atomic number 11. The first one takes 2 electrons, the second one takes 8, meaning you have 10 now, remaining 1. The 1 is this one, because this one means electron, the red one means electron. The white one shows the space for electron, meaning there's no electron here, but it's a space, possible space electron can fill. That's what it means. Don't think, oh, this white one means electron. It means it's an empty space where electron can be attached. Okay, so for sodium, there's only 1 electron in the outermost shell. So a sodium atom has 1 electron in its outer shell, right? Now let's see what does sodium now need to do, like we explained before. Sodium need to lose this one, need to give it out to a needy atom, another atom that needs this 1 electron. Okay, it needs to lose it, it needs to give it out. So when it loses it or gives it out, it becomes an ion. So for sodium ion, the number of protons will still be 11, the number of neutrons is still 12, but the number of electrons has characteristically changed. The number of electrons has changed. So there's no third shell. See the first shell and see the second shell only. Third shell is no more, it's gone. Why? Because it has given this electron out, so no need for empty shell. We only have only the first and second shell. The third shell is gone because the only electron it has given it out. So it becomes positively charged, become a cation. Sodium atom lose their outermost electron, leaving 2 full shells of electron. The first one complete the first 2 electrons, maximum, which is the first shell must have maximum of 2 electrons only. First shell cannot go beyond 2, only 2 electrons. Second shell now holds the 8 electrons, and which makes it 2,8 only, 2,8 only. First shell 2, second shell 8, and we put plus here. Remember, in the IGCSE exam, you have to put this big square bracket and put a plus because it gained 1 electron. It lost 1 electron. You put a plus here because it lost 1 electron. If it loses 2, like magnesium, you put 2 plus here. You put 2 plus here. You must remember to put this, okay? They are in the exam paper. Now let's move on quickly. So what you see in sodium atom is that it has 11 protons, 11 electrons, because number of protons and number of electrons are same. That's why an atom is said to be electrically neutral. They may ask you why are atoms said to be electrically neutral. Atoms are electrically neutral because number of protons, which is positive, equals to number of electrons, which is negative. Positive and negative balances itself out. That's why they are neutral. They don't unless they lose electron or they gain electron. So as it stands, number of protons equals to the number of electrons, we say the atom is electrically neutral, meaning no overall charge. No one has a net charge, no positive. If you minus them, you're going to get 0. Positive 11, negative 11, we cancel out, so the atom is neutral. However, when the atom loses an electron to another atom, number of protons will still be 11, but it has lost 1 electron. So electron is now 10. So there's 1 extra plus charge. That's why we used to write 1 plus here for sodium. That's why we write only 1 plus here for sodium. There's extra because it's now more, the positive is more than the negative. The positive is more than the negative. The positive is 11, the negative is 10. So for that singularity, we say an atom is now a cation. This atom is now an ion, which is called a cation because it has lost 1 electron. Because it has lost 1 electron and it has become positively charged. Okay, I hope this is clear. Let's move on to, in the case of an ion, the formation of an ion. For an ion are negatively charged ions. They are negatively charged ions. Anions are negatively charged ions. So what happens is that some atoms like chlorine, for example, let's use chlorine to cite this example. Some atoms like chlorine, they have several electrons in the outermost shell. Why? As we have shown, 287. Chlorine's atomic number is 17. Chlorine's atomic number is 17. So the first shell holds 2 electrons, second shell holds 8 electrons, and the third shell holds 7 electrons. So chlorine we require a less energy to gain 1 electron, to look for 1 electron, than the energy to push out several electrons. The energy to push out several electrons is far greater than the energy to look for 1 electron. So chlorine will now decide, okay, what is best for its interest. For chlorine's interest, it's better chlorine just look for 1 electron because the energy to look for 1 electron is way smaller than the energy required to get rid of several electrons. So since that's what's more suitable for chlorine will look for 1 electron, and add to this will be 8. If it adds the 1 to it, this will be 8, and it will have a full outer shell electrons. So chlorine may probably negotiate with sodium and say, Sodium, Mr. Sodium, I heard you want to give out your 1 electron. So please, can you give me? I am actually looking for 1 electron. So Mr. Sodium, we give Mrs. Chlorine 1 electron. We give Mrs. Chlorine 1 electron without payback. He's not asking you to pay back. That's why it's called ionic bonding. When you come to the bonding, when we start explaining the bonding, it's an ionic bonding. It's about ions. You lose, this one gain. You lose, this one gain. It's about ion. When you lose, you become positively charged. You become a cation. When you gain, you become an anion, and you become negatively charged. So it is easier to gain 1 electron, for chlorine to gain 1 electron, than to lose 7 to achieve a full outer shell of electrons. So it's easier to gain 1 than to lose a whole 7. Even logically, it doesn't make too much sense that you just 1 point away, and you say you want to give out the whole entire 7. It's not almost logically possible. Okay, so it's more wise to look for 1 and complete your outer shell. Now, chlorine has a space for 1 electron. That's why you have this small circle. It means empty space for 1 electron. The first shell takes maximum number of 2 electrons, and the second shell takes 8 electrons, and the third shell takes 7 electrons. So that's for chlorine atom. Number of protons, it's 17, which is positive. Number of electrons is 17, which is negative. Now for the atom, for the ion, this is for the atom. For the ion, chlorine gain 1 electron, so it has more electrons now. Electrons will be 18. Electrons are now more than the protons, which are positive. So negative is now more than positive. So that's why chlorine becomes negatively charged ion, becomes an anion, -1. That's why we put minus here when we put the equals bracket in the ions. When we draw the ion, we put bracket, we put minus here. If you forget to put minus in the exam, you will go to lose 1 mark. Trust me, if you forget in IGCSE exam to put negative here, you're going to lose a mark. Okay, now let's move on quickly. Okay, we'll move to the second part of our today's work, which is bond. What is ionic bonding? Now, since we've explained ions, now it's time for us to see how they bond, how atoms bond themselves together. Now we're looking at the formations of ionic bonds. Now, ionic compounds are formed when metal atoms react with non-metals. It's always between metals and non-metals. Because the sodium we use as an example, sodium is a metal. in group 1. Why is it in group 1? It's in group 1 because it loses 1 electron. Okay, sodium loses 1 electron. So to become sodium ion. If you lose 1 electron, to become sodium ion, you'll be in group 1. If you lose 2 electrons, you'll be in group 2. Like magnesium loses 2 electrons, you will be in group 2 in the periodic table. If you lose 3 electrons like aluminium, you're going to be in group 3. Why is aluminium losing 3 electrons? Because the atomic number is 13. Aluminium, the atomic number is 13. You must know the first 20 elements in the periodic table in your heart. You must know them in your mind, okay? Atomic number is 13. So if you draw the electronic configuration, you have first share 2, second share 8, and third share 7. Okay? Third share 3 electron. Because it's 13, right? 2 plus 8, 10 plus 3, 13. So these 3, aluminium has to lose the whole 3. It's easier to lose 3 than to look for 5. Because if you want to complete the outer shell, the energy to lose 3 is smaller than the energy to look for 5. So you will lose this one. That's why aluminium ion, that's why when it lost 3 electrons, it becomes a cation. And the aluminium ion becomes what? 3 plus. Because it lost 3 electrons. And because it lost 3 electrons, it will be in what? Which group in the periodic table? It will be in group 3. The number of electrons you lose in your utmost share determines the group you'll be in the periodic table. And the number of your share, if you count your share, 1, 2, 3, determines your period. If you have 3 shares, 1, 2, 3, you'll be in third period in the periodic table. If you have 2 shares, you have been period 2. Is that okay in the periodic table? Remember that. Number of shares determine your period. The number of electrons you lose in your utmost share, the number of electrons in your utmost share determines your group in the periodic table. The number of electrons in your utmost share determines the group in the periodic table. In the case of sodium, it has 1 here, so sodium will be in group 1 in the periodic table. Magnesium has 2, you'll be in group 2. Aluminium has 3 in the utmost share, you'll be in group 3. Silicon has 4 here, you'll be in group 4. Okay? So on and so forth. So let's take a look at the formations of the bond. How do the bond takes place? Ionic compounds are formed when metals react with non-metals. Now, in this case, what are the metals? We talked about sodium. What is the non-metal? When it reacts with what? Chlorine. Chlorine is a non-metal because chlorine has to gain electron, right? It has to gain the 1 electron, this one lost, to become, so you become sodium chloride. You become sodium chloride. Okay? So you become sodium chloride. That bonding, you lose 1 electron, you give this one, that bond, that relationship, that force to become a new compound, to join together. Because actually, like they form a compound. To form a new compound, instead of sodium element or chlorine element, they become sodium chloride. To become sodium chloride, which is a table salt, common salt that we use, to become a different substance, the bond that exists between these 2 elements or 2 atoms, you can use the word element or atom interchangeably. Okay, the bond that exists between these 2 elements or 2 atoms to become a compound, compound is when 2 or more elements chemically combine together. When 2 or more elements or 2 or more atoms chemically combine together, it becomes compound. When 2 or more substances physically combine together, they become mixture. That one becomes mixture. But compound is when 2 or more atoms or elements chemically combine together. So when they chemically combine, there's a bond, a force that holds them together. That force is called ionic bonding. That bond that holds them together is called ionic bonding. Why is it called ionic bonding? Because it's coming from ionic reaction. This one lose electron, this one lose 1 electron, this one take it from me and form and join together as one union. So that bond is called ionic bonding. Is that okay? And it normally, take note, ionic bonding is between a metal and non-metal. It's not between 2 metals. When that one is metallic bond, when between 2 metals or between the same metal of different atoms. So that one will be a metallic bonding. But when it's between a metal and a non-metal, it's called ionic bonding. When it's between 2 non-metals, it's called covalent bonding. When it's between 2 non-metals, like carbon is a non-metal, oxygen is a non-metal. So, in fact, from group 4, group 5, group 6, of group 5, group 6, group 7, they are non-metals. So when it happens, when the bonding happens, this is called covalent bonding between non-metals. Group 1, group 2, group 3, they are metals. We have metals, group 1, group 2, group 3, and then we have transition metals, which are between group 3 and group 4. We have a lot of transition metals, which are used as catalysts in many of the time in the chemical reaction. group. The traditional methods are used as catalysts. They are used to form color compounds, and they have high density. Remember this property in the exam. They always ask this question in paper 4 in Cambridge IGCSE. Now let's move on quickly to the next one. We say the metal atoms, they lose their outermost electrons because they are unstable now. They need to give it out. They want to give it out. They lose it, and the non-metal, they gain it. Okay, so when this type of bonding happens, when one atom lose electrons in the outermost shell, and the other one gain the electron from to add to the outermost shell, that kind of bond is called the ionic bonding. Now the positive and the negative ions are held together by strong force. By strong force, the positive and the negative, they're held together by strong electrostatic force of attraction between the opposite charges, between the positive and the negative. There's a strong force, and that strong force is what we know called the ionic bonding. The force of attraction, the strong force of attraction of positive and negative attraction that exists between metals and non-metal is called the ionic bonding. It's called the ionic bonding. Now let's briefly take a look at the dot and cross diagram, which I have already explained. The dot and cross diagrams are used to show the arrangement of electrons in the shells, in the outer shells of electrons in any electronic configuration. An ionic or covalent compounds or an element. So you can use the dot across to show in ionic, in covalent, in compounds or in element. Now the electrons are shown as dots and crosses. So if you have two atoms reacting together, you can use dot for one atom to differentiate it from the other one. If you use this one for sodium, let's say sodium ion, if we use dot for sodium ion, we can use cross for the other one, which is chlorine. So just to differentiate, because if we use cross and cross or dot and dot, we may be confused, right? We don't know which one has given to which one. So you can see it here now that this sodium has given the third share, the only one electron in the third share, he has given it to the chlorine. This is the dot, he has given it to this. So this one no longer has a third share, only first share and second share. And he has lost one electron. He has lost one electron, and so he has given it to this. So the dot across is just to differentiate the electrons. Okay, so this kind of bonding, or the electrostatic force of attraction that exists between the sodium ion and the chlorine ion, the positive ion and the negative ion, that electrostatic force of attraction existing between these two atoms, or these two ions in this case now, is called ionic bonding. In case in the exam they ask you to define ionic bonding. An ionic bonding is an electrostatic force of attraction that exists between the positive ion of metals and the negative ions of non-metals. The force of attraction that exists between the positive ions of metals and the negative ions of the non-metals. Is that okay? That force of attraction. So you can see in the case of chlorine, first share is 2, second share is 8, third share that was supposed to be 7 is now 8 because it has received one electron from sodium. It has received one electron from sodium. So it's complete. Its outer share electron is 8. You know the goal is to have 8 in the outer share of electron. This one, outer share of electron is 8. So here we have 2,8 now. 2,8. The one that was supposed to be in the third share has been donated. So no more one electron in the third share. No more third share. That one has been donated to this chlorine. So chlorine here will now be the chlorine ion in this regard will be 2,8. Instead of 287, it has gained one mole electron from sodium. It becomes 288. So this one becomes 288, and so it's good to go. Okay, let's go to the ionic bond between group 1 and group 7. The bonding is between, because group 1 has one electron to give, group 7 has 7 and is looking for one to add to it. Now the bonding for group 2 will be group 2 and group 6. So when you bring group 2, because group 2 has 2 electrons to give, group 6 has 2 electrons to complete, right? Bonding will be between group 2 and group 6. Bonding will be between group 3 and what? Group 5. Between group 3, I'm using Roman numbers. Between group 3 and group 5. See how the bonding takes place? No, between group 4. Group 4 is covalent bonding. There's no ionic bonding in the case of group 4. Now the first one is between group 1 and group 7. Because why is that so? Group 1 has 1 electron in their outermost shell. And so group 7 is looking for 1 electron in the outermost shell. So this one will give only 1 electron it has in the outermost shell to group 7 like chlorine that is looking for 1 electron in the outermost shell. Is that okay? Now, group 2 like magnesium, it has 2 electrons in the outermost shell. It will give to oxygen. You know oxygen atomic number is 8. Oxygen atomic number is 8, right? So since the atomic number is 8, this atomic number is equal to number of proton. And this number of proton is same as number of electrons. You know we use electron to do electronic configuration. Since it's 8, the first shell will be 2, the second shell will be 6. So since the second shell is 6, it's looking for 2 to make it 8 in the outermost shell. And group 2, magnesium, can give this 2 to it. Magnesium can give this 2 to this one. Or magnesium can give to chlorine, but 2 atoms of chlorine. In this case, it will be chlorine 2 atoms. It will give 1 to 1 chlorine atom and give another 1 to another chlorine atom. It become magnesium chloride. Okay, not only 1 chlorine, because it has 2 to give. It cannot give only 1 chlorine, like in the case of sodium. So you give 1 atom to 1 chlorine. You know here it has 2 chlorine. So this one you can write like this, magnesium. You write 1 magnesium here. And you have 1 small chlorine here. 1 chlorine atom and another chlorine atom. So this magnesium, because it has 2 electrons in the atmosphere, can give 1 to this one and give 1 to this one. That's how we got magnesium chloride with 2. MgCl2. Okay? But in normal C, other normal C, it has 2 electrons. Oxygen is looking for 2, so it can give to form magnesium oxide. It can give the 2 electrons to oxygen, because oxygen is in group 6. Oxygen is in group 6, and magnesium is in group 2. So magnesium can give 2 electrons in the atmosphere to oxygen in group 6. If you're in group 6, it means you have 6 electrons in your atmosphere. Remember I said the number of electrons you have in your atmosphere determines the group you are in the periodic table. If you have 6 in your atmosphere, you are in group 6. So since is in group 6, it's looking for 2 electrons to complete 8. It's looking for 2. And magnesium has 2 electrons in its outermost shell, because magnesium has 2, 8, 2. 2 in the first shell, 8 in the second shell, and 2 in the third shell. So in this third shell, it has to give this one out. These 2 it gives, this one will receive to make it 2,8. This one will receive it to become 2,8. To become 2,8 instead of 2,6. And to be stable, to be okay. So this kind of bonding between metal and non-metal is called ionic bonding. It's called ionic bonding. Group 3, like aluminium, we give to group 5. Which element will be in group 5? Like nitrogen. Because atomic number is 7. If your atomic number is 7, your first shell will be 2. Your first shell will be 2. Okay. Your first shell is 2, and your second shell will be 5. So if you are 5, you are looking for 3 to be 8. And it's easier to look for 3 electrons than to give a whole 5 out. So aluminium that has 3 in the outermost shell, is 2,8,3, right? Aluminium has 3 in the outermost shell. These 3 electrons, it can give it to nitrogen, okay, to form aluminum nitride or so. Or it can give it to whatever, any one that has 5 in the atmosphere. Is that okay? So that's what is playing out in this. And like I said, the electrostatic force that exists between metal and non-metal ions are called the ionic bonding. Now let's move on. Let's use a diagram to show this concept. Now let's take sodium. I think we've done this already. Sodium has 1 electron in the atmosphere, right? The first shell is 2, second shell is 8, and the third shell is 1 in the atmosphere. This white one means empty. It just means how many you need. You need 7. So to look for 7 is too cumbersome. It's better to give out your 1. So you give 1 to chlorine that has 7 in the atmosphere, and chlorine becomes this. This bonding that exists, or this force of attraction, the electrostatic force of attraction that exists between ions, or metal ions and non-metal ions, is called the ionic bond. It's called ionic bonding. Okay, we move on to another case where we have both form stable ions with full shell. Now this one is stable because it has lost 1. This one is stable because it has gained 1. When it becomes ion, remember we must put bracket. I said this. We put this bracket so that you put the plus here for the one that has lost electron, and put this bracket and put the minus here for the one that has gained the electron. So there's an electrostatic force of attraction between the oppositely charged ions. So that electrostatic force of attraction between these oppositely charged ions are called ionic bonds. They're called ionic bonds. So please take note for your IGCSE. Okay. So sodium and chlorine, this is what happens. You now have sodium ion and chlorine ion. Is that okay? Let's move on. Now we go to the lattice structure of the ionic compound. You know, ionic compound, this is also an exam question. They form what? The lattice structure. They form a very strong structure, not easy. That's why salt is they form lattice structure. They can ask what's the structure of ionic compound. They are like this. They can ask you to draw a diagram to show it. So you represent it like this. This is the structure, or you use them to you draw like this. Why this one means for chlorine, and this one means for sodium. So you draw a structure like this. They're very strong, not easy. Ionic bonds are very strong, not easy to penetrate. They form giant lattice. Okay, ionic compounds have a giant lattice. They may ask you to give the characteristics of ionic compound in the exam in Cambridge IGCSE. Okay, they form a giant lattice structure. The lattice structure refers to the arrangement of the atoms of a substance in a 3D form like this, like in a 3D form. So this is how it's being formed. This, if you want to show it in 3D, you show like this, or you show like this, you will get the marks in the exam. Now the lattice formed by the ionic compounds consists of the regular arrangement of alternative positive and negative ions that is formed in sodium and chlorine, that is shown in sodium and chlorine. Okay, ionic bond between metallic and non-metallic elements. Okay, these are for extended students for the exam. I have explained this when I say magnesium oxide. When I say magnesium has 2 electrons in the atmosphere, oxygen has 6 in the atmosphere. It's looking for 2. Magnesium will give its 2 to this to become magnesium oxide. The big question is, why is it MgO? Why not Mg? Because we simplify to the lowest term. You know, remember how the formula, chemical formula form. You know, this one has 2 electrons, right? 2 plus. Okay, 2 ions, because it donates 2 ions. Oxygen gain 2, sorry, it donates 2 electrons. Oxygen gain 2 electrons to become 2 minus. Now, when we are doing the chemical formula, we don't put them, we forget the plus minus. So we cross multiply. This one has 2, this one has 2. So when you cross multiply, this will give you Mg2, this will give us Mg2. I want to show you how this formula, chemical formula are formed. We can do calcium and any other thing we can use so that you see how they are formed. This becomes Mg2, Mg, because you cross multiply. You know this is the symbol of magnesium. If you cross multiply with these 2, you write Mg2 here. You write Mg2 here. And if you cross multiply with this, you write O2 here. You write oxygen 2 here. But why is the formula not written like this in real life? Why? Because when you have 2 and 2, you simplify to the simplest form, to the lowest term in ratio. You bring it to the lowest term ratio. So meaning it's like you divide here by 2, divide here by 2, it becomes what? Only MgO. It becomes only MgO. But if they were not the same number, then you don't have to do that. It becomes MgO. The G is small letter, the M and the O are capital letter, okay? You don't have to do that. My this is lagging. I hope you understand. So it becomes like this. But what if you have, in the case you have 4 and 2, let's say here, for example, let's say you have 2 here, let's say you have M, my writing is laggy, okay, you have 2 here, and the O you have 4. What if it's 2 and 4? You also simplify to the lowest term. So you divide here by 2, become Mg, and this one divided by 2 become O2. Is that okay? So it's always like that. Okay, let's move on. Magnesium is in group 2 in the periodic table and is a metal, so it loses 2 electrons because it has 2 electrons in the atmosphere, and so because of that, it will lose this one to have full outer share. You lose the 2 electrons to have full. So because of that, it becomes plus 2 ion, plus 2. Oxygen is in group 6. It is looking for 2 electrons to complete its outer full shell, and so it will gain these 2 electrons. And so what happens at the end of the day? They will form MgO ion. The bonding, the electrostatic force of attraction that exists between the ions of metals and the ions of non-metals is what we call the ionic bonding. So magnesium lose 2 electrons, this one gain 2 electrons. The 2 is lost from the, they only showing the outer shell, what remains. The first shell is 2 here. They'll say, oh, why is there no first shell? In many exams, they will tell you, oh, we are only representing the outer shell, what remains in the outer shell. Okay, so you can see the outer shell electrons here is now 8, and the outer shell of electron here is 8 because magnesium has given the 2 in the third shell, he has given it to oxygen, and its outer shell is now complete 8 or so. Okay, now let's take a look at the properties of ionic compound. I think we will end with the properties of this part of our today's study. So the properties of ionic compound. Ionic compounds are usually solid at room temperature. They're solid, they're strong, they're solid. Salt, like table salt, they're solid. They're solid, take note of that. If they are solid, they should have high melting point and high boiling point. So one point gives you the next idea. Since they are solid, ionic compounds are solid, then they should have high melting point, high boiling point, high density. All of this you begin to flow in your mind. They begin to flow in your mind, okay? And they can conduct electricity when molten, right? Or in solution. They can conduct ionic compounds or ionic property. One of it is that they can conduct electricity when they are in molten state or when they are in solution. Take note. They are poor conductor in solid state. When they are solid, they are like insulator. In solid, they're not easy for you to conduct. They are poor conductors or they are insulators in solid state. But when you dissolve them in water, that's the meaning of solution. When you dissolve them in water, they will be able to conduct. Or when you put them in molten form, like you put them like in powder form, they will be able to conduct electricity. Okay, so take note. Ionic compounds are solid. They have high melting point, high boiling point, high density, and they can conduct electricity in molten or in solution, and they are poor conductor in solid state. Okay, so we move to the next one. Say explain the properties of ionic compound. The extended part, what they need from you. Extended means those science students. Okay, when they say extended means science student. When it's the one that is not extended, it just means that the combined science. We call it combined science or integrated science for people who are not doing science, but they just take the subject just to have scientific knowledge. Okay, but if you are doing real science today, you need to understand the extended part. Okay, if you are doing paper 4, you are already in extended. Okay, ionic compounds, they have high melting point. These are extended students should state it in the exam. A high boiling point. Okay, what this means is that they have a very big giant structure, which will show the lattice. We explain the lattice, and they have strong electrostatic force of attraction that is holding the oppositively charged atoms or ions, holding the charged ions together, right? And the forces needs a lot of energy to overcome them. You need a lot of energy to break them. So as extended student, you need to be able to explain this point. The reason why they have high boiling and high melting point is because they have giant structure, and again because they have very strong electrostatic forces holding them together, the opposite and negative, the oppositely charged ions together. And the third one is that the energy to break that electrostatic force is super huge. The energy to break the force holding them together is super huge. Then the second property for ionic compounds are that they are poor conductors in solid state. So this one you should be able to say, poor conductors. Why? How to explain it as an extended student is that you say they are poor conductors. The ions are in fixed position. That's why. When they are solid state, solid, they are in fixed position. So the ion, there is no electron moving. For something to conduct electricity, the electron has to move, has to become a mobile electron. The ions are in fixed positions, and they are therefore unable to move to carry the charge. They are not able to move to carry this charge. Since the ions are in fixed position, they are not able to move to carry the charge. So this is why they are poor conductors. Now the third property I say that you should be able to explain as a extended or science student, the third one you should be able to explain as a science student includes this following. He said ionic compounds, they are good conductors of electricity in molten or in solution. Now how do you explain this? They are good conductors. When the ionic compound is melted, when you melt it, that is in molten form. That's the meaning of molten. When you melt it, it's in molten. Okay, when you melt it, it's able to conduct because they will have the charge will be able to move to carry the electrons. Okay, to carry they will be able to move from place to place. The electrons are able to move. So then it can conduct electricity. or when in solution also, they are able to move to conduct electricity. So the ions are able to move, to carry the charge. Ions are able to move. Please take note, the ions will be able to move when they are in motive or in dissolved form, okay, to carry the charge. Now, the greater the charge on the ions, the stronger the electrostatic force that is holding the ions together, and then the higher the melting point or the boiling point. Is that okay? For example, magnesium oxide consists of two ions, magnesium and oxygen, two ions. So we'll have higher melting point than the case of sodium. Magnesium has two ions, so the melting point and the boiling point of this one will be higher than that of sodium. Sodium only has one ion from this and one ion from this. Magnesium has, in the case of aluminium, that has three, will be higher than this one. Is that okay? So that's how it goes. Now let's look at the diagram to show the electrical conductivity of ionic compound. Like this is what happens. Install it from their fixed position. You can see the ions, the charges of the ions are in fixed position. They are in fixed position. So they cannot move to carry the charge. The ions cannot move to carry the charge. When you now make it in motive, when you melt it or in solution, when you dissolve it in water, they are able to slide over each other. So the ions are able to slide over each other, so they're able to carry the charge from one place to another. Therefore, it will be able to conduct electricity. So I think here we come to end of part 1 of chapter 3. So our next class will do covalent bonding and covalent compounds. Thank you for joining us.